Foldit is a multiplayer online game in which players compete and collaborate to find well-folded protein structures. Proteins are molecules fundamental to life. They are often called the machines of the cell. Understanding their structure can help to fight diseases like AIDS, cancer, and the flu, develop novel biofuels, create cheaper commodity chemicals, and lead to other benefits. Foldit is designed to be played by people who have no biochemistry background. The concepts, visualizations, and tools necessary to play the game are taught by a series of introductory levels. These are offline puzzles with a set goal score that players are meant to reach. The score is based on an energy function provided by the biochemists. It's based on the principles of well-folded proteins, so that a better folded protein will be higher scoring. The levels have context-sensitive hints that guide players to the solution. For example, this red bubble is a void. It's a visualization that shows where there's undesirable empty space in the protein. The most basic interaction in the game is pulling on the protein. When players complete a level, they are rewarded for success with fun animations and sounds. Once players have progressed through the introductory levels, they can compete in science puzzles. This is where we put the puzzles for which scientists are interested in the outcomes that players produce. In these puzzles, players can interact with a variety of tools. Players can manually pull on the protein to place it where they want, freeze parts to keep them from moving, and place rubber bands to pull in multiple places at once. They can also take advantage of automatic tools that let the computer do the fine-level optimization. The gamers can use their structural problem-solving skill, and the computer can do the number crunching. By letting the players and computers each do what they're best at, we hope to solve problems that neither humans nor computers could solve alone. These science puzzles are accessible online, usually for about a week. During that time, players reshape the protein to try to find the highest scoring folds. For these puzzles, even we don't know the highest score possible. Therefore, the puzzles are organized as leaderboard competitions, so players set ever higher goals for each other. We found that in certain cases, folded players are able to outperform purely computational methods to accurately predict protein structures. Foldit players even recently solved the structure of an AIDS-related protein, where all previous experimental and computational methods failed. One interesting aspect of the game is that the different players are not just trying to find well-folded proteins, but also good strategies for folding proteins. To see if players could codify their strategies in a systematic way, we gave players the Foldit Cookbook. This allows players to code their algorithms in a visual block-based language or a text-based scripting language. Players can then automatically execute their low-level strategies. This allows them to focus on the higher-level strategies they can't automate. Players can also share their algorithms online, edit and run other players' algorithms. The algorithms can undergo a social evolution. We're also working on allowing players to design entirely new proteins. These are proteins that don't exist in nature and can have entirely new and useful functions. For example, we're currently running a series of puzzles challenging players to design a flu inhibitor. We're able to take the player designs from the game and test them in the lab. In this way, we can make their designs real and see how effective they are.